number 4, we are going to be solving this rational inequality. Now, one thing that we have to realize about rational functions is the only way that a rational function can change signs is either through one of the discontinuities, in other words, by going through a asymptote or a point, or the other option would be to go through one of the zeros, similar to a polynomial changes signs. So what we have to do first is identify any discontinuities and intercepts that this polynomial has. This rational function has. So this is going to be similar to any other rational function that we looked at. So first we will take the zeros, or the x-intercepts, and that we do by setting the numerator not to 0. And so we have a 0 at x equals negative 4. We then look at our denominator. Now remember, the zeros of the denominator, that is where we have either point discontinuities or we could have asymptotes. So over here, I'm going to factor this thing out. 2x squared plus 9x minus 5. And we know that this cannot equal 0. Factoring that, we get 2x and x. This is going to be 5 and 1. That will be positive. That will be negative. So we have vertical asymptotes at x equals 1/2. And we have another vertical asymptote at x equals negative 5. So these are the only places that we possibly could change signs looking at this. So we're going to make what is called a sign line. And a sign line is just a number line. And we're going to put the zeros as well as the vertical asymptotes on this line. So here we go. We're going to put negative 5, negative 4, and 1/2. Now we have to determine the sign of this in each one of these different intervals. So if I am less than negative 5, say I plug in negative 6, and again, just like we were doing earlier, all we really care about, do we get a positive or negative? So I plug negative 6 in there. My numerator is negative. In the bottom, it's easiest if we plug it into the factored form. If I plug a negative 6 in there, that's going to give me a negative number. If I plug a negative 6 in here, that's going to give me a negative number. So overall, if I am extremely negative, I have a negative number. So anytime I am less than negative 5, I am negative. Then I look in between negative 5 and negative 4. So let's look at negative 4.5. If I plug in negative 4.5 into here, that's going to be negative. Negative 4.5 into here, that's going to be negative. Negative 4.5 into here, that's positive. Positive, positive. Negative, negative makes positive. 3 positives is positive. So I am a big plus in between negative 5 and negative 4. I plug in a value in between negative 4 and 1/2. Easiest value, if I plug in 0, I get 4 in the top, negative 5 in the bottom. Everything just zeroes out. So that is going to be negative. If I plug in a large number, everything's going to be positive. So if I plug in 10, I have positive, positive, positive. So there's a plus. So now this is called a sign line. What you need to notice is that we are doing or equal to inequality in this problem. So the negative, as I'm looking, the intervals that work are between negative 5 and negative 4. Because negative 5 is a vertical asymptote and you can never include a vertical asymptote as part of your answer, this is still going to be a parentheses. Now, because we have or equal to, and the negative 4 is a 0, that will be a bracket. And then we will union that, and we'll come over to this 1/2. And again, this 1/2 is associated with a vertical asymptote, so we will not include the 1/2. And we will go off to infinity. And that is number 4.